Good morning, everybody, and welcome to our monthly webinar. If you have not already, please go ahead and put your full name and your lab number in the chat so that we can mark you for attendance. And we are going to go ahead and get started. So as I said, welcome everybody to the February Web LDMS Introductory Training Webinar. My name is Claire Hall, and I am the lead LDMS trainer at Frontier Science. This is session number 1 of 2. Both sessions cover the same information, and both sessions are being recorded. As a reminder, we ask that you stay muted during the call, and please ask any questions you may have using the chat feature of this Google Meet webinar. Today, we are going to briefly go over what is LDMS, important resources and contacts, special equipment, and then we will do our LDMS walkthrough. So who is Frontier Science? We are a nonprofit research organization with over 35 years of clinical trial experience. We act as a trusted data management center and statistical center, and we provide software solutions for managing biological specimens. One of those pieces of software is the LDMS platform, or the Laboratory Data Management System, which is a comprehensive LIMS. The LDMS software is fully validated and compliant under 21 CFR Part 11, meets NIST and FSMA guidelines, and follows Frontier Science's software development lifecycle. The primary functions of LDMS are managing specimen inventory, configuring virtual storage, and facilitating data exchange between sending and receiving laboratories. Additionally, data can be exported from the system to Frontier Science, which can then be packaged and sent to other data centers as needed. The diagram on the lower half of the screen walks through how data comes in and out of LDMS. The LDMS workflow is multifaceted. Many clinical trial networks utilize LDMS to help track and manage specimens collected during studies. LDMS was designed for specimen inventory management, allowing you to extension your primary and aliquot specimens. You can create virtual storage that is representative of your physical storage configurations. And LDMS can help manage specimen shipping and related documentation by curating the data set that will accompany the physical specimens. LDMS will also allow you to receive aliquot specimens from a sending laboratory, and LDMS can also capture certain testing results, as well as generate exportable data sets for internal documentation or external use. LDMS is a web-based platform. This means multiple users can perform data entry in LDMS simultaneously, as long as they have stable internet connection and access to a web browser. Users can view all data additions and updates as they occur. Data is actively being sent to the cloud data servers at Frontier Science in real time, and there is no need to backup or export your web LDMS database. LDMS is utilized by the sample processing labs, testing labs, and repositories. Labs participating in these clinical trial networks will now have streamlined and standardized specimen data that is collated at Frontier Science into larger network databases. Data packages can then be sent on to statistical centers or other data centers. If Frontier Science is your data management center, then LDMS data is compiled at Frontier in combination with submitted relevant clinical data for respective trials and studies. We will now review some important resources and contacts. First, we have project documentation. If you are participating in any specific clinical trial networks, project-specific guidance will be on our website, ldms.org, under a section called Project Documentation. This is where you will find specific memos, slides, documents, and quick reference guides, which are specific to project or clinical trial network you are participating in. Next, we have our Frontier Science YouTube channel, at FSTRF Films. This is where you will find our previously recorded public-facing webinars that will be viewed at any time. These webinars can be used for refresher trainings, for self-trainings, or training new team members that join your staff. Next is the LDMS training team. They are going to be your resource for training, to schedule training webinars, and you can reach out to the training team at any time. Our contact information is listed here, ldms.training@frontierscience.org. The last resource is LDMS user support. User support is available 24/7 with the exception of a few US holidays. They are going to help with user account setup and provide new users with their login credentials. LDMS user support is also going to help diagnosing any problems that you may be running into while utilizing the platform. And user support can help troubleshoot label printing as well as barcode scanning. You can contact them via email at ldmshelp@frontierscience.org, via phone, or via the Contact Us utility on the ldms.org website. Next, let's look at some special equipment you may need to utilize depending on the clinical trial network you are participating in. If you are going to be utilizing the barcode scanners in LDMS, you will need a compatible barcode scanner that will be able to extract the global specimen ID from the 2D barcodes that are generated. Additionally, if you are going to be generating labels from the LDMS platform, remember that you need to print those labels on appropriate specimen label stock that must be adhered to each individual specimen. Labels must be printed from an Adobe PDF viewer, such as Adobe Acrobat or Adobe Reader, or the proprietary software that accompanies the label printer. Please do not print the label, please do not print the label PDF document out of your browser. We will walk through that in today's training. The next slide is a reminder to any lab managers or administrators on the training today to keep your contacts up to date. You can do that by accessing your Frontier Science portal account. You will navigate to submit contact changes, and here you will select your appropriate lab, and you'll be able to update your team members. Keeping your contacts up to date is very important, especially if there are personal data updates, such as name or email change or personnel turnover. As a reminder, LDMS user accounts are created and maintained by LDMS user support. To perform the following tasks, you would need to contact LDMS user support for assistance, creating a new user, managing what features in LDMS a user can access, or resetting a user's password. Of note, users are able to modify their own passwords within LDMS, provided they know their login credentials. To submit account-related questions or other general issues or questions, navigate to Contact Us on ldms.org and select Assistance with Login Credentials or Using LDMS. Your submission will automatically open a service ticket that will be sent directly to LDMS user support. We are now going to begin our walkthrough of LDMS. We can access LDMS in two different ways. The first is navigating to ldms.org and clicking LDMS login in the upper right-hand corner of the screen. Oh, and I ask that you please mute if you are unmuted, make sure you are muted. Thank you. All right. The first way is navigating to ldms.org and clicking LDMS login in the upper right-hand corner of the screen. Or the other method is navigating to webldms.org in your browser of choice. We recommend that you use Mozilla Firefox, Google Chrome, or Microsoft Edge, as these are the three browsers that the Web LDMS platform is validated on. Once again, I ask that you please mute your mic. If you are unmuted, please mute. Thank you. So, on the LDMS website, I am going to use my login credentials.
So I think that's why. Then,
Now, if you are a new user, you will have received a login ID and a temporary password from LDMS user support. The temporary password will expire after 24 hours. And once your password expires, you will need to reach back out to user support to receive a new temporary password in order to complete your account activation. Once you have logged in with your login ID and temporary password, you will be brought to this training acknowledgement form. This form confirms that we have participated in some kind of LDMS training and keeps the platform in compliance with 21 CFR Part 11 regulations. Training consists of attending a webinar such as this, reviewing any of the previously recorded public-facing webinars on our YouTube channel, reviewing any of the documentation or user manuals on the LDMS.org website, or being trained by a fellow team member in your lab. You will need to select Yes, I have been trained, submit your login ID and temporary password once more, and then click Submit. You only need to complete the training acknowledgement form once after the first time you log in to activate your LDMS account. Now, I have one extra step. As a super user, I will be choosing the practice database that we will be using for this LDMS walkthrough. So I'm going to click Log In, and this will bring us to our welcome screen. When you enter LDMS, you're going to be brought to this welcome screen, and I'm going to zoom in a little bit and explain some details at the top of the screen. In the upper right-hand corner is where you are going to see your user profile information. This will include your full name, your LDMS lab ID, and your time zone. Please make sure that this information is correct and aligns with the user who is performing the data entry. To the right of the user profile information is the logout button, and by clicking the drop-down menu next to the logout button, you will see that you can change your password. If you need to reach out to LDMS user support, you can click the Help button, and this will direct you to the Get Help utility at ldms.org. At the end of your session, we ask that you log out completely and you do not allow your browser to save your password and username. This is not only an IT best practice, but as LDMS is recording all transactions that occur within the web platform, we want to make sure that there are no accidental logins by another user, especially in a lab where there may be shared workstations. We want to make sure that the individual who is performing the data entry aligns with the user profile that is logged in. Now, the navigation pane at the top of the screen will allow you to navigate between the different modules. These include specimen management, storage, shipping, reports, labels, test results, data submission, administration, and online resources. Online resources has embedded links to direct you to different resources, LDMS validation resources for your end user validation process, the Frontier Science website, the Frontier Science portal, and the specimen repository websites for those participating in certain clinical trial networks. The first module we are going to walk through today is the administration module. I'm going to navigate to lab settings, and only certain users will have extended permissions in order to access this feature. The lab settings function is going to have a series of features that you can turn on and off, and these features will be the default settings for your laboratory's LDMS database. The first checkbox we are going to look at is Process Tech Initials defaulting to current user, this very first checkbox. When this is turned off, no processing tech initials will be associated with the aliquot or primary specimens. Thus, you will need to manually add those initials to the respective primary and aliquot specimens. But when this feature is turned on, the initials of the user who is logged in will be associated with the primary and aliquot specimens created, and this should only be checked if the technician who processed the samples is the same technician that is entering them into LDMS. I will leave this feature turned on for today's training. The next feature we will discuss is the checkbox for Require a Comment when modifying primaries and aliquots. When this feature is turned off, a comment will not be required if specimen modifications are made. When this feature is turned on, modifications to primary and aliquot specimens will only be saved if a comment is also placed in the comment field. This is a change control process feature which we encourage teams to use. This is a nice feature to use in order to make sure that comments are added when any specimen changes occur. This can include a general post-processing update or resolving data discrepancy in response to a query. However, we understand it can be a barrier to your workflow efficiency, and we leave it up to labs' discretion if they choose to use this feature. I will leave this feature turned on for today's training. Our next module that we are going to discuss is the specimen management module. The specimen management module is where specimens can be added to the database. These specimen records can be viewed in an index-like user interface that are organized under their respective unique participant. Participant records are dynamic, allowing users to see all specimen records associated with a study or visit. The specimen management function will allow us to view our specimen inventory. And again, specimen management is going to be organized by individual participant records, which will have project and participant information at the top left corner of the record, and then showcase all study visits and specimens associated with that participant. To navigate through the different records, we have a few options. We can slide to find a specific participant. We can use the left and right arrows to move one participant record at a time. We can use the first and last arrows to jump from the first to last record. Or we can use jump to participant if we know the project and participant ID. You can also utilize filters on the left-hand side of the screen to narrow down results. And these filters include storage filters, shipment filters, specimen filters, visit filters, enrollment filters, and participant filters. Applying filters will reduce the number of projects you are viewing based on the filtering criteria we have provided. As you can see, when I apply the project filter Frontier, we can see the number of records we are looking at has gone down significantly. To remove a filter, select the X next to that individual filter, or to remove all filters at once, click the button Remove All Filters. The participant record is dynamic, allowing us to see all protocols or studies, visits, and specimens for a specific participant on one screen. The first level of dynamic functionality is going to be in the ID2 protocol study field. And as you can see, this is a drop-down menu available showing me that different protocols this individual is enrolled in. If I select any of the protocols listed from the drop-down menu, we are going to see the visit grid, primary grid, and aliquot grid update, showing us those visits and specimens specific to this protocol. The next level of dynamic functionality is going to be at the visit grid. The visit grid is going to show the visit value in units, the collection date, the ID3 or sub-protocol ID, and the clinic value. Now, as I toggle between the two visits selected, you will see the primary grid and the aliquot grid update, showing us those specimens collected specific to that visit. Our last level of dynamic functionality is going to be at the primary grid right here in the middle. If I toggle between the two different primaries, if I toggle between the two different primaries, we are going to see the aliquot grid update, showing us those aliquot specimens specific to the primary selected. I'm going to select week 2, primary specimen number 4. The primary grid and the aliquot grid are going to share a lot of features. The first feature is going to be the global specimen ID, which can be seen here in the first column. The global specimen ID is the unique LDMS identifier that is assigned to all specimens the first time they are logged into any LDMS database. This ID will travel with those specimens even if they are shipped to a different laboratory. The global specimen IDs are going to begin with your LDMS lab ID number, followed by an alphanumeric string, and then end in a 3-digit code. The primary specimen and aliquot specimens are going to be linked by their global specimen ID. They will share the same parent upstream alphanumeric sequence and be differentiated by the ending 3-digit code. All primary specimens will have a 000 ending, and all aliquot specimens will have a range of 001 through 999, allowing us to have 999 aliquots derived from an initial primary specimen. In this example, we can see that we have 52 specimens derived from this one specimen. Our next column in both grids is going to be the status column. The status column is going to show a series of icons that will either be colored in or grayed out. This will indicate to us any flags assigned to the specimens or the physical status of a specimen. When I hover over the different icons, we will see a text box telling us what the icon means. We have the following icons. We have a gray or green circle showing if the specimen is physically available in our lab. We have a gray or blue freezer icon showing if a specimen has been assigned to the storage module of LDMS. We have a gray or yellow envelope icon showing if a specimen has not been shipped, is flagged for shipment, or is on a pending shipment, or has been shipped. And a gray or brown clipboard indicating if the specimen has been assigned for testing. The primary grid also has one additional icon, this dual figurehead. This icon indicates that the primary specimen has been co-enrolled between studies in order to reduce the collection burden on the participant. The primary grid will have our collection details. This will include collection time, primary specimen type, the additive type, the specimen condition code, and the available volume and units. Similarly, in the aliquot grid, we will have the derivative type, any sub-additive or derivative or reagent information, the specimen condition code, and available volume and units. Now we are going to accession specimens into the database. We can do that by using the quick add feature within the specimen management module. Before I go into this quick add example, are there any questions I can answer? Looking briefly in the chat, I don't see any questions. And I don't see any raised hands, so we will go ahead and keep going. So from the specimen management drop-down menu at the top of the page, I'm going to select Quick Add. Again, Quick Add is going to be where we will add specimens to our database. We can add specimens a few different ways, and I'm going to walk through each of these. Please note that some of these examples that I'm going to show may or may not be relevant to the clinical trial network you are participating in. So please review your project documentation and follow the requirements of the clinical trial network you are a part of. For example, certain clinical trial networks require the use of quick add templates, while others require a manual entry. I will be performing both of these today to demonstrate the different methods within the quick add function. So you can see that the quick add screen has data field names that should look familiar. They are the same as the fields we saw in the participant record. We have participant information, enrollment information, visit information, and the primary and aliquot information. So as I said, the first method that I'm going to use to add specimens is going to be performing a quick add manual entry. So first, I'm going to add the project. And then I will add our participant ID. We will make that today's date and add an A at the end. Our protocol or study for the enrollment field will be study 1. And I can either type in our study information or I can utilize the drop-down menu as you saw me just do, depending on how your project is set up. Next, we're looking at visit information. I'm going to put in our ID3 information or the sub-protocol ID or record number. I'm going to put ARM A. And I will then choose our clinic value from the drop-down menu. We are going to put clinic 1. And then I will define our collection date. Clicking the drop-down menu will populate a calendar, and I can click today to populate today's date. I can choose a date from the calendar, or I can type in our date in the day, month, year configuration. I am just going to click today. I will then define our visit value in units, which will be 1 for the first visit, VST. So to recap so far, we have defined our participant information, our enrollment details, and our visit details. And next we need to define our primary and aliquot specimens. So in the primary grid, we are going to see this Add New button over here in the right-hand side. I'm going to click the Add New button. And when I click Add New, LDMS is going to populate our first primary specimen. it is automatically going to populate to whole blood or BLD. If I need to, I can change the specimen type by clicking the drop-down menu or by typing in the 3-letter code defining our primary specimen type. If I hover over one of them, I'm going to get a text bubble indicating the definition of those codes. 3-letter codes are going to be used to define your visits, your visit units, your primaries, your additives, your conditions, and so on. And you can find the list of all of our 3-letter codes in the back of our user manual. In this example, I'm going to leave the specimen type as whole blood. I'm going to make the additive EDTA with the code EDT. I'm going to keep our condition code at satisfactory. And next, I'm going to define the collection time and the receive time. And as a reminder, LDMS uses a 24-hour clock. I will input the collection time as 6 o'clock. And the collection time is the time at which the primary specimen was collected directly from the participant. The receive time I will define as 6:30. And the receive time is the time that the processing lab received that primary specimen. Finally, we will define our primary specimen's volume, and we will define that at 10 milliliters. Now let's look at the aliquot grid. We can see this says aliquots for primary number 1. I will click the Add New button twice. This will allow me to create 2 different aliquot types as a result of primary specimen processing. First, I'm going to define the total number of aliquots. I'm going to have 3 of each type of aliquot. The value in this field will indicate to LDMS to create 3 records of each specimen type we are creating. Now I will define our 2 different specimen types. First, our first aliquot is going to be a derivative type of PL2, or double spun plasma. Our subadditive is going to be Na. Our condition code is going to remain satisfactory, and our volume will be 1 milliliter. Our second derivative type is going to be a derivative type of PBMC cells. So we have the code CEL, which stands for PBMC cells viable. Our subadditive or derivative type is going to be DMSO, so we will have the code of DMS, and this is used as a cryopreservation solution. The condition code is going to remain at satisfactory, and the volume value will be 3, and the unit will be cells, CEL. And when the derivative type is PBMC samples, the volume unit will always be cell. Built-in LDMS logic will apply a 1 million multiplier to our volume value, allowing us to create PBMC records that are 3 million cells per specimen. So to recap, we clicked the Add New button in our primary information area. We defined our first primary collection as whole blood with EDTA. We defined our collection time, receive time, and volume value and volume units. And then we clicked Add New twice in the aliquot area, and we defined our 2 different aliquot types. As a reminder, these aliquots are the result of processing the primary whole blood. We then defined our 3 double-spun plasmas and our 3 PBMC samples. Now, if the visit had a second or third primary collection, we can add those primary specimens by clicking Add New in the primary grid. And as you can see, the new primary section has populated and our aliquot grid refreshed, allowing us to define the aliquots associated with primary number 2. The primary collection is going to be a urine sample with no additive. So our code will be URN for urine, and our additive type will be NON for none. Our condition code will remain at satisfactory. Our collection time will be 6 o'clock, and our receive time will be 6:30. And we will define our volume value in units at 10 milliliters. There we go. Now for our aliquots, we are only going to click the Add New button once. And we are going to update the aliquot total to 3. Since we are making 3 smaller urine aliquots. In this example, we are not going to be transforming the urine into pellets and liquid, so we are going to keep the urine samples as whole URN for urine. The subadditive or derivative type will be not applicable. The condition code will remain at satisfactory, and the volume of the 3 specimens will be 1 milliliter. Now, as I toggle between the 2 different primaries, the dynamic functionality should look very similar to our participant records. We are seeing the aliquot grid update, showing us those aliquots related to the primary selected. Once we have put in all of our participant, enrollment, visit, primaries, and aliquots information, I can then click the Add button at the bottom of the screen. Now, as long as everything has been correctly added to our quick add screen, we will see the successfully added note at the top of the page, telling me that I successfully added 3 double spun plasmas, 3 PBMCs, and 3 urine aliquots. From here, I will click the Print Labels button, which will allow me to generate labels for this set of 9 aliquot specimens we have created. Zoom out a bit. There we go. If we have accessioned our specimens under a specific project, I will have default label formats predefined for me. In today's example, I'm going to generate an LDMS label that includes a standard 2D barcode. I'm going to change the format to ACTG spec barcode, and I'm going to change the size to 19. And then I will click Generate Labels. This is going to create a PDF document, and as you can see, it automatically downloaded to my Downloads folder. As a reminder, depending on your browser settings, you will either see your documents automatically downloaded to a specific location of your choice, or you will have a pop-up asking you to open or save the document in a specific location. Please review these browser settings when you are utilizing LDMS to know where your documents will be downloaded. I have opened our label document here, allowing us to view the PDF. Here we have our 2D barcode. Then we will have our global specimen ID, our participant ID and protocol or study, our collection date and time, our primary and aliquot details, and lastly, we will have our volume and visit details. In order to print these labels, I do not want to print them from the print button in our browser. I want to take this document and open it in Adobe Acrobat or the proprietary software that came with the label printer. This will make sure I have more robust printer settings, which will allow me to adjust the intensity and burn of printing to make sure that our barcodes are printed at a high enough resolution to be successfully read by the barcode scanner. So once we have printed our labels, we want to verify they have printed successfully before we adhere them to our specimens. I'm going to check this by opening up a blank Excel document. There you are. So we will open this document and we will click within it, making sure our cursor is in it. And then we are going to go to our barcode and we are going to scan it. There we go. Now we are going to see our global specimen ID populate in the document, which aligns with the global specimen ID of the label we scanned. This is a note that any labels created prior to the version 11 release on February 23rd will still have that FSQ control characters in front of the global specimen ID, which occurs when scanning a barcode outside of the LDMS platform. All labels created after the deploy of version 11 will not have the control characters in front. So as we can see, there is no FSQ in front of what I have just scanned. Now I'm going to set those barcodes aside for later, and we are going to navigate back to the LDMS platform. The next way we are going to add specimens to our database is going to be utilizing a quick add template. This is going to load information onto the quick add screen predefined by our project or clinical trial network. I can utilize the template drop-down menu and try to find it in this very long list. There we go. We have this long list on the left-hand side of the screen, and I can try to find my template from this long list. And this list is also going to have the templates that are available across all clinical trial networks. I want to use a template filter to reduce the template list to find what I am looking for. So under Project, I'm going to filter on Frontier. And now when I go to the template dropdown, we can see the number of templates listed has significantly reduced. I'm going to choose our Visit To template. LDMS is going to ask if I want to load the template data. When I click Yes, LDMS is going to populate the information here onto this quick add screen and clear out any information we have already started to add. You can see that the project has been populated and our study has been populated. Our visit value and units have been populated. And then our primary and aliquots have been populated as well. Here we have our whole blood with EDTA that is going to become double spun plasma and PBMCs. And I can toggle to primary number 2. And here's our urine collection with the 3 smaller urine aliquots. So even though this template does most of the work, I do have some fields I still need to fill out. We will put our ID 1, or our participant ID, as the name we created today, of today's date with the A at the end. We will put in our ID 3, which we are going to have ARM A. We are going to put our clinic value of 1. And we will define our collection date as today's date. Now, because our primaries and aliquots have already been defined, when I click collection date, LDMS is going to ask if I'd like to cascade this collection date through to our received date and processing date of our samples. LDMS would like to assume that all of these activities happened on the same day. If this information is incorrect and you do not want to cascade that information, you would click no, and then you would be able to manually type in your received date and processing dates. But when I click yes, we will see the collection date and receive date were populated with the same value. Lastly, I need to define collection time and received time. Now, if everything is collected and received at the same time, you can copy and paste within these fields to help reduce your data entry burden. For example, I can type 6 o'clock in the collection time, then I will highlight it. I will click Control-C on my keyboard to copy, and then I will click the box for the other collection time and click Control-V to paste. We will do this again for our received time. We will put 6:30 as our time. We will highlight it, Control-C, click in the other received box, and click Control-V. There we have copied and pasted our times and had a little less work to type in. Next, I want to review how to use condition codes. In this example, the primary urine sample was not collected, so no urine aliquots were created. I'm going to go to our condition code of the primary and set the sample to set it to sample not collected. So we are going to type in SNC for sample not collected. I will then set the condition code of the urine aliquots as well to SNC for sample not collected. I'm going to still have a record of these 3 urine samples, but there are going to be 3 unavailable samples that were not collected. The method of adjusting the condition code instead of utilizing the delete button to remove specimens is preferred by clinical trial networks while using a template. This allows LDMS and the data management centers to keep a record of expected collections. In this example, we expected to have 3 urine aliquots, and will explain why we do not have them. I am now going to click the edit button of these aliquots, and this is the edit aliquot window where we are going to see the aliquot details. I am going to update the reason the specimen was not collected for this example. I will use the drop-down and click on Optional Specimen Not Processed and I will click Save. This comment will be associated with each of those 3 urine aliquots, and the specimens will be physically unavailable, but there will be a record of them, which I will show you in a moment. Clinical trial networks will usually have a condition code workflow or flowchart describing the scenarios in which certain condition codes are being used and the appropriate scenarios to use them. Please refer back to your project documentation to make sure that you're utilizing the condition codes appropriately. So to recap, I have applied a project filter to help me find my templates. I then chose our templates from the drop-down menu, and we confirmed that we wanted to load the template data. And then we put in our participant ID, our ID3, our clinic, our collection date, received date, collection time, and receive time. Therefore, I didn't have to put in as much information as I did with a manual entry. Now I'm going to click Add, and we will see our successfully added note telling us we have added these to the database. Our last way to add specimens to our database using Quick Add is going to be utilizing multiple participant IDs. First, I'm going to utilize a template in today's example. We are going to filter by project, so I'm going to type in Frontier. And from the reduced list of templates, I'm going to pick Visit 3. And yes, I would like to cascade. So now I can add a participant, and we are going to add the one that we have added earlier. Now I also have a Google Sheet that has 3 additional participant IDs on it. These people will be coming into the clinic today. I'm going to save this as a CSV file. And that now is in my Downloads folder. So I will now upload that file here using the Upload ID file button. I'm going to select my sheet. I will get a note saying that LDMS has parsed out 3 participant IDs from our file, and I will click OK. Here are those 3 IDs, and here are those, here are those 3 IDs listed, and I can always modify this list by deleting participants with the delete button and add individuals back in by manual input. But now we have a list of 4 PIDs, 1 we entered manually, and 3 we entered by file. A note about the multiple participant IDs. If you are going to be using this feature, we want to remind you to pay attention to your visit information. When you are using the multiple ID feature, you will be creating the same set of specimen records for each individual participant you have listed. This is a great feature to use if you have multiple participants arriving at the clinic on the same specified day for the same visit and same collections. The only information that would need to be left out is the collection time and the receive time, because maybe I don't know when the individuals are arriving at the clinic today. So now I will put the rest of our information in. We will put our ID3 as arm A, our clinic value as 1, our collection date and receive date will be today, and I am going to leave our collection time and receive time blank because I don't know what time those participants are coming to the clinic today. Again, this is a great tool to use if multiple participants are having the same collections done for the same visit details on the same day. But if multiple participants arrive throughout the day and they are there for different visits and different collections, I would recommend against using this multiple participant feature as you'll have to go back and revise your specimen records for each of those individual participants. I'm going to click the Add button at the bottom of the screen. And we are going to see our specimens that we have created for these individuals. So we have our participants A, B, C, and D, and all of their associated specimens and aliquots. Now, before I move on to post-processing, do we have any questions? So I do see a question in the chat asking, at what point would you report processing time after you have logged collection time and received time? I'm going to let Felicia jump in if I'm incorrect, but Felicia, correct me if I'm wrong, would that best time to be when the product is, or the process is received?
Yeah, so processing time can be added during specimen entry in the quick add function, as Claire is showing. There's an edit button where you can add processing time. If you don't know processing time at the time of specimen entry, Claire is going to show you how to perform post-processing, where you can go in and edit the specimen record and update that processing time value to the primary specimens that were collected.
Thank you so much, Felicia. I don't see any other questions in the chat, so we will go ahead and move on to post-processing, which will hopefully answer a little bit more of that question. So I'm going to navigate back to specimen management. So I've navigated back to the specimen management function, and we will look for the records that we have added through our different examples today. In order to find our specimens quickly, I'm going to utilize a visit filter, and I'm going to search on collection date, which we are going to define as today's date. Our specimen records are going to be reduced to just those records that we have collected for today. We can see it's down to just 4 participants. In order to find our specimens quickly, or excuse me, here is our first participant that had visit 1, 2, and 3. We can see the collection time is listed. And then we have our 3 other participants that we also uploaded. We uploaded those from the multiple PID entry, and you can see that there's no collection time associated with these participants. If we navigate back to our first participant and we click on visit 2, and we click on our urine primary, we are going to see that this is the visit where the urine aliquot samples were not created. You can see in the status column in the aliquot grid showing that these specimens are not available. These specimens are not physically available because they were not created, but we do have the record of the expected collection with the condition code SNC for sample not collected. We also have the reasoning why these specimens were not created. If we click the edit button for any of these aliquots, we can see the reason given. Here we are. We can see the reason specimen not collected is listed as optional specimen not processed. For our next example, I will navigate to visit 3, primary specimen 1, which is our whole blood sample, or BLD. So now that we've added our records to our database, our next step is going to be performing post-processing on these specimens, and we can apply post-processing. We can apply post-processing a few different ways. The first is going to be going to the edit menu of that primary specimen that does not have a collection time and a receive time. So we're going to go ahead and click edit. This is going to open up our specimen details, showing us all the fields associated with our specimen. Any of these fields that are available here can be modified. So I'm going to update the collection time, receive time, and processing time of this whole blood as they were previously not defined. So we're going to set the collection time to 6 o'clock, the receive time to 6:30, and the processing time to 6:45. Now I'm going to click the Save button. And when I click Save, we will see a pop-up notifying me that a specimen has been modified and I need to enter a comment in order for our change to be saved. So I will type in the comment field that I added collection, received, and processing time. I will put my initials and I will put the day's date. Then I will click Save. And now I will get a confirmation telling me our comment has been saved. And I will also see a request asking if I want to cascade that comment through the respective aliquots. I'm going to click Yes. And this comment here will now be associated with this primary, but also to the associated aliquots as well. Now when I go to any of these aliquots associated with the whole blood sample and I click the Edit button, we are going to see the processing time. Here we are. we are going to see that the processing time has been added and our comment has been added as well. If I need to do post-processing to any of our aliquots, I can do that from the edit menu as well. In this example, I need to update the processing tech initials. So here we have them currently as CH. I'm going to change them to ABC. And then I will add a comment saying that I have updated tech initials. I'm going to put my initials and the date. And I'm going to click Save. Now I'm going to get a pop-up asking me if I want to cascade these changes I made to this aliquot or to the other aliquots. I can cascade this comment and change to none of the other aliquots, all of the other aliquots, or only aliquots of the same derivative type. If I want to cascade this change only to the double-spun plasma samples and not the PBMC samples, I will select only aliquots of the same derivative type, and I will click OK. Now we can see on the double-spun plasmas, we can see that the processing tech initials have been updated, and we can see our comment saying we have updated the tech initials is listed. This will be true for all three aliquots. The other way to update aliquots simultaneously is to use the multi-select feature by clicking the control key and highlighting all the samples you are interested in evaluating. In this case, I'm going to select the PBMC samples by holding down the control key and clicking each one. Now I will click the edit button. You can see in our edit window that it looks a little different, as all of the fields are grayed out. However, there are checkboxes next to each field, and in this example, I am going to update the available volume by selecting that checkbox. I will then clear out the current value of 5 million and replace it with 3 million. Lastly, I will need to add a comment. And then I will click Save. This time you will notice that I did not have a pop-up asking me if I wanted to cascade that information through the aliquots because I did it through a multi-select feature. If I click Edit on these PBMCs, we will see that available volume has been updated and our comment is listed. Other features of our participant records are going to be the drop-down menus next to the edit buttons of our aliquot specimens. This will allow you to assign tests to any of the specimens, mark your specimens to ship, or print labels of each individual specimen as well as your primaries. Specifically for our PBMC samples, we are also going to have an additional feature. We are going to have the cryopreservation feature. The cryopreservation details, in the cryopreservation utility, I can click Results Obtained and then fill out additional information about HIV status, primary specimen details, aliquot details, and technician details. And any changes I make on this screen, I want to click the Save button in order to implement those changes. Now we are going to pause here for a 10-minute break, but before I give us the pause for the 10 minutes, are there any questions I can answer? I don't see any new questions in the chat. So we will go ahead and we will take a 10-minute break. Okay, here we have a follow-up question. Is it possible for the system to have a locked string on these values fields, collect, receive, and processing prior to submitting the primary and aliquots? Now, Felicia, I'm going to ask if you want to step in on this one because I'm actually not quite sure.
Sure. So let me see. Processing date is not a required field for data entry. For successful specimen record entry through the quick add module or quick add function. If you are, I'm not sure if we can program that for a specific study or trial. So if you would like to email the LDMS training team your question about making the processing time a required field, go ahead and do that to the ldms.training@frontierscience.org, and we can discuss internally and get back to you with an updated answer.
Thank you so much, Felicia. All right, I don't see any other questions in the chat. And so I will just give another reminder while we get this 10-minute timer started to please put your lab number and your full name in the chat if you have not already. If you have, you are all set. But if you have not already, please put your name and your lab number in the chat for all people participating from your computer. But for now, we will have a 10-minute break. So go ahead and enjoy, and we will be back at a little after about 9:11, 9:12. Alrighty, welcome back, everybody. I hope you had a nice little 10-minute break. We are going to go ahead and we are going to go back into LDMS, and we are going to talk about the storage module. So as I said, next we will cover the storage module in LDMS. The storage module can be accessed from the navigation pane and by selecting stored samples. Labs can use the storage module to assign specimens to virtual storage locations that reflect the lab's physical storage workflow. Labs can use the storage module to assign specimens to virtual storage locations that reflect the lab's physical storage workflow. The storage tree functionality allows users to visualize how specimens are stored in containers, which can be stored in a rack, on a shelf, in a freezer. Users are able to customize the different storage levels with flexible 2D configurations that represent their physical storage solutions. So here in our example freezer, example 1, -80, I will start with the freezer, and then I will have the shelf that is on the freezer, and then I have the stainless steel rack on that shelf, and then I have the boxes that are in that rack. Some of the boxes contain specimens, so when you see that plus sign next to a box, that means that the tree can be expanded, and you'll notice a set of brackets before the name of each specimen, and those brackets indicate the individual positions. So this specimen is in position A1 in our container, which is in position 1 on our rack, which our rack is in position 1 on our shelf, and our shelf is in position 1 in our freezer. So to create new storage, I'm going to go to the Actions drop-down menu here on the left, and I am going to click Add Storage Unit. This is going to allow me to create a new storage unit. This is going to be a freezer, a refrigerator, a liquid nitrogen tank, or so on. So we are going to name this freezer. So we'll go ahead and name it. The name is already in use, so I will put a CH at the end. So we have named our freezer 01 freezer CH. The type is going to be freezer. The temperature is going to be -80, but you can see I have a full list here from liquid nitrogen all the way down to room temperature. And next I'll define our rows and columns. So rows and columns will give us a 2D representation of what our freezer looks like. This freezer is going to have 4x1 sections. And each of these sections is going to have its own shelf configuration that we are going to design next. So I'm going to be using the same, if I'm going to be using the same configurations frequently, I can save this as a template. I can do so by going to the bottom and checking off the box that says Save as New Template and typing in a name for that template. And when I click Save, that will create our template for me. So I will uncheck that, and I'm going to click Save to create our freezer at -80. And see, we have our freezer right here. Our next step is going to be adding the shelf configuration. I will click the drop-down menu next to the Edit button for our freezer, and we are going to see a few different options. I'm going to select Add New Level. So if I have a template available, I can use that. So I'm going to use the 1x4 shelf template. This gives me 4 individual positions within the shelf, and I'm going to use this configuration because each of these individual positions will hold a 5x5 stainless steel rack. I will give this the name Shelf 1, and I will click Continue. I will now designate where the shelf configuration is within our 2D structure of the freezer. So here are our 4 freezer sections, of which I can choose any, but I'm going to choose section 1, and I'm going to click Save. And this will be our designated Shelf 1. Our next step is going to be adding a stainless steel rack to our shelf. So from the Edit drop-down menu for Shelf 1 specifically, we are going to click that drop-down and we are going to click Add New Level again. Again, I'm going to use a template. I'm going to choose the 5x5 stainless steel rack, meaning that I have 25 available positions. I'm going to give this the name Rack 1, and I will click Continue. I will now choose where the rack resides within the shelf. So here are those 4 positions. Again, I can choose any of them, but I'm going to choose position 1 for this example, and I'm going to click Save. So as a review, I assigned the rack to position 1 of Shelf 1 in position 1 of our -80 freezer. Our last step is going to be creating the containers that we will assign specimens to. With our rack specifically selected, we are going to go to that drop-down menu one more time, and we are going to go, instead of Add New Level, it says Add New Container. I have one additional feature when adding new containers, and that is by adding multiple containers simultaneously, as long as they have the same configuration. I'm going to add 6 boxes. I'm going to do our template for 9x9 numeric alphabetic box. And as you can see, we now have a 9x9 box with 81 available positions. Right now, positions only is turned off, allowing me to apply row and column labeling. The box currently has a numeric alphabetic labeling configuration, giving me a coordinate pair system for our 81 individual positions. If I want to, I can adjust that column labeling as well as that row labeling, using the appropriate nomenclature that best fits the workflow in our lab. I can also turn positions only back on, which will give me those 81 available positions. However, I'm going to have that turned off for this example. The last step before I click Continue is I want to review fill order. The fill order is a set of instructions we give LDMS to automatically assign specimens or containers to the next available position. And we will want the fill order to follow our physical work or workflow. Left to right, top to bottom is pretty standard for a 9x9 cryo box such as this. Starting with position A1, we work our way across the top of the box, and then we work our way down all the way to our last position in I9. However, depending on the specimen type you are storing, you may want to adjust the fill order in order to reflect how you're placing specimens within the container. For example, if you are stacking them on top of one another, say you have dried blood spot cards or test tubes, you may want to do bottom to top or something like that. So it's good to practice to always review your fill order before you create your containers. Now I will click Continue. I will update our box name to be O1 Box 1. And I'm going to utilize the autofill from select positions feature, which will allow LDMS to automatically fill the rack by following the fill order of the rack and placing our 5 boxes in positions 1 through 5 without me having to click and continue and confirming each individual position, therefore saving me time and effort. So I'm going to click Continue. I can see that plus sign next to rack 1, and I clicked that to reveal our boxes. Now let's discuss if I wanted to delete a box. I will need to give a reason for deletion every time I delete anything within LDMS, and this will show up on the user event report, which we will review later. To delete a box, I'm going to go to the Edit drop-down menu next to that box, and I'm going to select Delete. When I select Delete, we will be asked to give a comment, or we will be asked to give different information. We are just going to click Delete. And now we have to give that reason for deleting the storage container. So I'm going to say we are testing deletion. I'm going to put my initials, and I will put today's date, and I will click OK. Now when I open this box or this rack, we can see that we just have boxes 1 through 5 now, and we have deleted box 6. So now that we've created our storage configuration, I'm going to start assigning specimens to these boxes. I can assign specimens a few different ways, and I'm going to walk through all of them. Some of these ways may or may not be required by your clinical trial network, so please review your project documentation to make sure you're following the requirements of your specific project. So for the first box, I'm going to store our plasma samples. So I'm going to click the Edit button of box 1, and I'm going to change the name from box 1 to plasma box. Then I'm going to click Save. To store specimens, our first method is going to be manual storage. I'll go to the drop-down menu for this specific container, and I'm going to select Store Specimens. This pulls up the specimen picker window that we saw earlier. Here we can see the same set of filters that we saw in specimen management. For this example, I want to filter on our collection date and our derivative type. So under Visit Filters, I am going to go under Collection Date and mark it today's date. And then under Specimen Filters, I'm going to go to Derivative Type, and I am going to search for those double spun plasmas. So we're going to put PL2. I only want to store the double spun plasma samples right now, so that is why I'm filtering on that derivative example. Now, when I select those two filters, I have 18 individual specimens available. If you look at the ID1 column, you can see that this is across multiple participants. If I have participant A, B, C, and D, but I only want to look at participant A, I am going to copy that participant's ID, and I am actually going to filter under Participant Filters, under ID1, we will select that ID. Now by scrolling back down to our pick list, you can see that I now only have 9 specimens. And now I'm going to either select all, or I can click the individual boxes with the checkboxes on the left. I'm going to select the first 3 samples, and I'm going to click Continue. Next, I'm going to use the autofill feature and assign these 3 specimens to positions A1 through A3, and then I will click Continue. Now our plasma box has that plus sign next to it, and when I expanded, we can see that we have those 3 specimens assigned to this box. Now, the second way that I can assign specimens into storage is by using our barcode scanner. And for this example, I'm going to store our urine samples in box 2. So first, I'm going to change the name of box 2 by clicking Edit and changing the name to urine box. I will click Save. And here we have our urine box. With our urine box now selected, if I look in the upper right corner of the window, I will see a plus sign over a barcode. This tells me that I can store specimens using our barcode scanner. You can see when I hover over with my mouse, I'm getting a text bubble telling me that I can scan our barcode to store our specimens or move our specimens. But if I go and at the rack, shelf, or freezer level, we can see that magnifying glass has changed, or excuse me, that plus sign has changed to a magnifying glass. Our pop-up tells me that I can search for a specimen within storage at these higher levels, but I cannot store a specimen at that high level, meaning I can only store specimens with the barcode scanner at the container level. So I'll go back to our urine box, confirm I have the plus sign there, and then we will move on. I am going to scan our first specimen. So I have my barcodes open. I'm going to make sure that I have my mouse selected in LDMS, and then I take my barcode scanner and I scan the ID. When I scan our specimen, the select positions window is going to open up. I'm going to confirm that the specimen is going into position A1, and I will select continue. I will then get a note telling me that the specimen has been stored, and I will do this for the second and third urine example as well. So I will scan it. I will confirm that it's going into position A2, and I will click continue. And I got my note telling me it's been stored. So we will do this one last time with our last urine label. Once again, I will confirm this is going into A3. I will click continue. So again, I used our barcode scanner to assign each of those individual specimens to our urine box. Next, I will demonstrate how to add more specimens to a box by using the auto-assign function. For this example, we will rename box 3 the PBMC box. Here we go. We have our PBMC box. So I'm going to switch our auto-assign function up here that says auto-assign storage positions. I'm going to check that box to turn this on. Then I'm going to select our PBMC box. I am going to store PBMCs using the barcode scanner as well as the select specimens function. So I'm going to go to the drop-down menu of this PBMC box, and we will see the option Store Specimens. Let's remove all filters. So first, I'm going to replace the filters that we just removed, and I'm going to search on derivative type of, we are going to put CEL for PBMC cells. And now I'm going to see the PBMC samples here. I'm also going to filter on participant ID. And here we can see the shortened list. I'm going to select 3 of these samples, and I will click continue. So now as soon as I click continue, those specimens were automatically stored in the box. And as you can see, we bypassed the select positions window because those specimens were automatically stored based on the fill order of the box. But now I'm going to repeat the process by using my barcode scanner. So I'm going to take my barcode scanner, I'm going to select the PBMC box, and we are going to scan a barcode. Oh, and it looks like I scanned the barcode for one that was already in this box. And it's asking me if I want to move it from its current position to a new one. I'm going to say no. Let's try removing one of these samples so we can see what it looks like when I scan with a barcode scanner. Remember, we have to put that reason for deletion. So I'm going to say I want to show the barcode scanner. I'll put my initials. Going a year ahead. There we go. So let's try one more time. I'm going to select that box. And I'm going to scan that specimen that I just deleted. So with the box selected, I will scan the barcode. There we go. So we will get that pop-up telling me that the specimen was stored. And you'll notice that the select positions window does not populate in either scenario because when the auto assign is turned on, the next items will be automatically stored by the next available position. This helps with your efficiency and timeliness as long as the fill order follows your workflow. However, it gives you a lack of control. If you need to move items around to specific locations within a box or create spaces, you may want to turn the auto assign off as you will have more control and flexibility on assigning items. So I'm going to head and turn that off. So now that we have stored items, we can move our items around as well. There are many different ways to move items, and the first way is going to be moving individual items. So let's go to a drop-down menu for the plasma box. When we can do this by selecting the item and we are interested in moving, going to the drop-down menu of that item and clicking Move this item. I can do this for specimens, for boxes, for racks, and for shelves. So in this example, I'm going to move this first plasma sample out of position A1, and I'm going to move it down into box 4. So I have the specimen selected. I've opened up the drop-down menu. I'm going to select Move this item. This pulls open our storage tree in a separate window. And now I'm going to navigate to box 4. Here we can see we have box 4. So I had opened up our freezer, the shelf, and the rack, and we found ourselves with box 4. And if you remember, our auto assign is turned off, so I will manually choose where these specimens are going to go. So these are going to be assigned to these different specimens. I will click Continue. And now we can see that that specimen has been moved out of position A1 from the plasma box into position A1 of box 4. So I can also move specimens with our barcode scanner. So if I want to move this specimen back into our plasma box, I will select the plasma box. I will find that barcode. And I will make sure I am selected inside LDMS, and I will scan that barcode. So now I can choose where that specimen is going to be within that box, and I can place it back in position A1, or I can place it somewhere else. And again, I have the auto assign feature turned off, giving me the flexibility to choose. I'm going to leave it in position A1 and click Continue. And now we will see that that specimen has been moved out of box 4 and back into position A1 of the plasma box. Now, if I want to move multiple items, I can go to the Actions drop-down menu, which is up here on the left. And I'm going to select Move Storage Items. This will pull up our storage tree window. And in this example, I am going to move all the specimens out of our plasma box and place them into box 4. So here's our plasma box. I'm going to select the individual plasma samples, as we can see here. And then I'm going to click Next at the top of the screen. Now I'm going to choose their destination. I'm going to open up the freezer I created, and I'm going to choose box 4. Oh, so we have a little bit of an issue here because I was selecting the box itself instead of the individual specimens. So what I was intending to do was to take those individual specimens out of that box and move them into box 4, but I have actually selected the whole box itself. So we are going to hit cancel and we are going to try that again. So I am going to click store specimens, or excuse me. We're going to the actions drop-down menu, excuse me. We are going to go to move storage items. And we are going to find those plasma samples. But this time I want to make sure that I'm not selecting the whole box. I'm just selecting those individual samples. Now we are going to go ahead and click next. And now we'll be able to choose their destination. Here we are. So I'm going to open up that freezer as I have, and I'm going to select box 4. I will then click the autofill feature, which will automatically fill the box starting from position A1. And I'm going to click continue. Now we can see our plasma box is completely empty. There's no plus sign. And when I go to box 4, we have our 3 plasma samples listed. Now the last way I can move items is by going once again to our actions drop-down menu and selecting move storage specimens filter search. So I'm gone to our actions drop-down menu, selected move storage items filter search. We are going to remove all filters and scroll down. Here we are. So this is our specimen picker window. And however, we only are going to see the specimens that are already in storage instead of the store specimens from the edit dropdown where we were seeing all physically available specimens in our database. This is only going to show us those specimens already in storage. So for this example, I need to find those plasma specimens and move them out of box 4 and back into the plasma box. I'm going to do this by utilizing our filters. So for participant filters, we're going to put in our participant A. And for our derivative type, we are going to search on PL2, that double spun plasma. And now we will see our 3 plasma samples at the bottom. So I will select these by clicking the check boxes. And this will allow me to move these 3 specimens out of box 4 and back into the plasma box. Once I click continue, I will then choose our destination. So we are going to go ahead and select the plasma box. And then again, I'm going to select the autofill feature, and we are going to click continue. Now when I open the storage tree, we will see box 4 no longer has a plus sign, it is empty, and those specimens have been moved from box 4 back to the plasma box. Now I can also generate some reports from storage. The first report that we are going to generate is at the box level. I'm going to go to our plasma box, and I'm going to click that edit button here. And on this page, we are going to see this reports button. This reports button will have a drop down next to it. I'm going to generate the container report. The container report is going to be a 2D representation of our box. X's indicate the empty positions, and our filled positions are going to have our specimen details. So here we have our specimen details, and here we have our empty positions. The legend is listed in the upper right-hand corner of the screen. And if you are creating your virtual storage ahead of creating your physical storage, you can then use this as a guide to keep your reports alongside your liquid nitrogen tanks to see what you have in storage and how they're organized. So the next thing I am going to report are at the freezer level. So the two reports that can be generated, which we will hit the edit button and go to the reports dropdown. Here we are. The two reports that can be generated are the storage detail report and the empty storage locations report. So the storage detail report is going to be a summary of the specimens in your storage unit at the level you selected. Because I chose the freezer level, we are going to see all the specimens and how they're organized within the freezer itself. We are only going to see each individual box starting from the freezer name all the way down to the box name. And then we are going to see all the individual specimens as well as their individual positions. And we'll see that for every box that has specimens in it within that level is selected. Next, we are going to generate the empty storage locations report. The empty storage locations report is exactly what it sounds like. It's going to show us all available positions within the containers assigned to that level. For example, we are going to see boxes 4 and 5 are completely empty. So we have 81 available positions starting from A1 through I9. The PBMC box, the plasma box, and the urine box, however, all have some of the positions filled and the remaining positions are empty. The last report we are going to generate is the print storage action report from the actions drop-down menu. The storage action report is going to be a running log of everything you've created and everything that has been moved or has been updated in location within the storage module. And you're going to see who performed those actions. So we're going to have a date range of today. And then I'm going to generate the report. So for example, we are seeing the actions that we performed during the session, and we are seeing who performed the action and the date it was performed. This is a helpful report if you have multiple users in the storage module performing transactions simultaneously, because it allows you to see the transactions that have occurred by your team members. Now, the next thing I want to do while I am in storage is I'm going to utilize our mark for ship flags. I'm going to apply these filters to boxes and specimens within the storage module. Then we can use those filters to find our individual specimens or containers within our shipping module to build our ship. So first, I'm going to mark the urine box for shipment. So the mark to ship flag is not mandatory to use in order to assign specimens to a shipment, but it is a helpful flag to help find specimens we might need later. So in the drop-down menu, I'm going to select mark to ship. In this window, I'm going to make sure mark to ship is selected, and I'm going to click save. Now we can see that flag we discussed on the urine box telling us this has been marked to ship. I'm now going to flag our plasma and our PBMC samples in their respective boxes. So we are going to go to the drop-down menu for each individual sample, and we are going to put mark to ship. So we can see that flag next to the first one. We're going to continue this process for the other samples. So we marked our plasma samples. We can see that we have the mark to ship flag next to all of those. Now let's mark some of our PBMC cells as well. Let's mark one more. Now we can see when I open my freezer down to the containers, we can see our urine box is flagged to ship. Our plasma samples are all flagged to ship. And 2 of our PBMC samples are flagged to ship. Now, before I move on going into shipping, do we have any questions? Looking in the chat, I don't see any. So I'm not hearing any, so we'll just go ahead and we'll keep moving. So next we are going to walk through the shipping module, starting with shipment history. The shipping module facilitates data exchanges between sending and receiving laboratories by compiling specimen records into a single file that matches the physical specimens being shipped. Labs are able to view their shipment history and generate relevant documentation that may be required by accompanying specimens during transit. Data files can be generated for each shipment and sent to the receiving laboratories or repositories. So shipment history is going to show a running log of all completed shipments imported or exported by your database, and this includes incoming and outgoing shipments. First, you will see a shipment number, an index, or a shipping number that is unique to your LDMS lab, meaning your shipment numbers are going to be different from somebody else's shipment numbers. We are also going to see the shipment type, meaning whether that shipment was sent or received. The shipment format, meaning the data file format for that data file that was associated with the shipment. The destination lab, the sending lab shipment number, the shipment temperature, the setup date, the shipment date, the received date, and the QA/QC status for all completed shipments. We can view a shipment by clicking the View button, and this will show us our high-level details, such as general information, shipping destination, contact at the sending lab, shipment notes, and the shipment contents. If we click the View button of the shipping container, we can also see the contents of the shipment itself. For example, how the specimens are organized in their container, and we can see the global specimen ID of the specimens on this shipment. From the View drop-down menu, I can generate any relevant documentation for our shipment, and for received shipments, I can perform QA/QC, confirming that I've received specimens as expected. For any outgoing shipments, I can download the shipping file that I need to send along with our physical shipment to our receiving laboratory. And that can be downloaded at any time after shipping is complete. Now we are going to navigate to pending shipments. To create a new shipment, we'll go to Shipping and we'll go to Pending Shipments. And we are going to select Add New from the Actions drop-down menu. And we are going to click Create Shipment. In our General tab, we will choose our intended ship date, which we will mark for today. And we will select our data file format. I'm going to leave it as LDMS, but if I was sending specimens to non-LDMS labs, I would choose a non-LDMS file type. I will also define our shipping temperature. I'm going to use dry ice for this example. I will now click Save, and this is going to give our shipment a batch number, 248. To continue, to continue creating our shipment, I'm going to click that Edit Ship button. I'll now go to Shipping Destination. And when I choose our destination, I can choose from our address book. And this address book is going to show all LDMS labs indexed by their LDMS lab ID. However, if I am working with a non-LDMS lab partner and they are not in the address book and I need to add them, I can click that New Lab button and enter the new shipping destination, and as well as enter the associated contact information. And then I would click Save Address at the bottom of the page and click Save to add this to our address book. Any new addresses saved will be in the address book, and they will have 999 in front of their name. If we choose a non-LDMS lab, we'll see the LDMS lab number locally saved as a lab ID. Now, if I navigate back to the General tab and I select on File Type, I'm going to get a flag telling me I cannot send an LDMS file type to a non-LDMS lab. This is because the LDMS file type is proprietary to the LDMS platform and can only be opened and viewed by LDMS. If I try to open the LDMS file outside of LDMS, it's going to corrupt the file and it cannot be opened at all by LDMS. So if I were sending to a non-LDMS lab, I want to make sure I change our file format to a non-LDMS file type. I'm going to choose CSV, and we will see that that flag has disappeared. However, I'm going to select the LDMS file format because I'm going to change our shipping destination to an LDMS lab. When I select an LDMS lab, we see the lab number populated as their LDMS lab ID, and the LIMS type is defined as LDMS. Now in the General tab, you should see that there's no flag at the data file format on the General tab. I can now define our contact person at the receiving lab, and if listed, I can choose from any of these in the drop-down menu. I can then define our contact at the sending lab. And then we can add any shipment notes. So we'll say we have no comments. The disclaimer is that this is dry ice. The shipment carrier will say is UPS, and we'll say we have a shipping number of 12345. Now, as a reminder, LDMS does not communicate with your carriers or couriers, and this is the lab's responsibility to coordinate your airway bill and packing label. But you can provide that information here, and it will be kept along electronically with your shipment. So first, let's go to shipment contents now. This is going to be our last step to adding our shipment contents, and I can do this in two different ways. I can add a container from storage, or I can create a new container and cherry pick our specimens that I want in the shipment. So first we are going to add a new storage container. We'll click Add New in the storage container level, and this is going to open the storage tree. Let's remove all filters first. Right now we are seeing the entire storage tree, and I can navigate to any box or container I want. If I open this up, we will see our urine box is right here. It also has the green flag indicating that it has been marked for shipping. But if I want to remove some of this clutter I'm seeing on the screen, and I only want to see the items which have been flagged for shipping, I can go to the ship storage container filters, and I can select mark to ship being yes. And now we can see this is reduced down to just our urine box. So I'm going to select the urine box and click Add Selected to Shipment. Now, if I want to create a new shipping container, I can click Add New, and this is going to be similar to creating a storage container. First, we will define our rows and columns. I'm going to create a standard 9x9 cryo box. We will now define our specimens on the shipment. So first, I'm going to choose our primary sort order. I'm going to choose specimen ID, but you will use the sort order required by your clinical trial network. Now I'm going to click Add Specimens. Now this opens our specimen picker window as we've seen before, and I've cleared out any filters, and this is going to show me all physically available specimens in our lab for shipping. So I'm going to use our shipment filter, and I am going to look for some of those flags we created earlier. So we are going to say mark to ship is yes. Now when I do that, I'm only going to see those specimens that were flagged for shipping. And as you can see, I have more specimens listed here than the plasma and PBMC samples that we flagged in our last example. So I'm going to look at the right, and I'm going to look at those ID ones. I'm going to filter by the specimen or by the participant ID we have been using today. And here we are. So if I wanted to, I could also use additional filter criteria such as specimen type or the PL2 or the PBMC cell derivative. But once I have selected our samples, which we can see right here, I will click Continue. Now I have our plasma samples that I marked to ship assigned in our new container, as well as those PBMC samples we selected. And I am going to click Add. And I now have specimens in our urine from our urine box and our plasma and PBMC samples in the new box we created. I'm going to click Save. Our next step is going to be creating the physical shipment. I can generate some reports to help with that. So I'm going to click on the Edit Ship drop-down menu to see our available reports. So first, let's generate the manifest report. Now, the manifest is going to update in real time as we add or remove data from our shipment, and this report can be generated at any time during the shipping process. It is showing whether QA or QC was performed, the shipment has not been shipped yet, what the intended shipping destination is, the notes, the contact at the sending lab, and I am also going to see the manifest itself. The plasma samples in the first box and the urine samples are going to be in the second box. Next, we are going to generate the storage report. The shipping storage report is going to give us a line-by-line description of where each specimen is located, from the freezer all the way down to the individual positions in the box. Each specimen will have its own set of information. Now, once I have our shipment prepared for this example, I'm going to generate our 1D and 2D barcode reports. You can generate these reports throughout the different modules of LDMS, and they will give a worksheet of barcodes specific to that shipment. The 1D barcode report is going to have 1D barcodes for your global specimen ID as well as your participant ID, and the 2D barcode report is going to have 2D barcodes instead of 1D barcodes. So now that I have our physical shipment set up, I'm going to our last step is going to be performing QA/QC before we click Ship. QA/QC is the chain of custody control process. So I went to the drop-down menu, I'm selecting QA/QC. So we can utilize our pass-fail buttons and manually review the individual specimens with our eyes and confirm or deny that those specimens are the correct specimens that should be on the shipment. Or the other way to perform QA/QC, and the way that is encouraged and recommended, and sometimes required by different clinical trial networks, is the use of our barcode scanner. Again, this is why we want to make sure our labels have been printed successfully to be read by the barcode scanner. So if we are performing QA/QC manually, we are going to utilize these pass-fail buttons. So with our first specimen here, I'm going to remove the physical specimen out of the box and review the details on the label. If the specimen's global specimen ID aligns with the global specimen listed, I am going to click Pass. I'm going to get an OK in that box, and I'm going to see the scanned ID listed as manual. LDMS is going to use the phrase manual to demonstrate that we did not use the barcode scanner, meaning we only used our eyes to evaluate the specimen details. This is the same with a failed specimen. Now, if I fail a specimen using the fail button, I'm going to see that exclamation mark in the box now, and we're going to see that means failure. And the scanned ID is once again listed as manual. However, if I use our barcode scanner, our QA/QC window will look a little bit different. So if I want to scan this barcode, I'm going to highlight that specimen and I'm going to scan the barcode. So we see that I got an OK, and I'm going to see when I click here that the global specimen IDs match, showing me that the scanned ID and the global specimen ID are the same. Now, if a specimen is incorrect, we are going to get an exclamation point, and I'm going to see the global specimen ID under scanned ID show me that they do not match. So let's take this sample here. And let's try scanning something that doesn't match. So we can see here that these two specimen IDs do not match. If a specimen is incorrect, but it should be on the shipment and it's just in the wrong place, you will see the correct coordinates populate in the correct coordinates row. But if a specimen is incorrect and it should not be on the shipment at all, we will see the correct coordinates listed as not found. Let's try that. Make sure this is selected. So we should see, it should say not found under correct coordinates. There we go. It will say not found under correct coordinates if this is not on the shipment at all. So I will now click Save, and I will look at what our QA/QC report looks like. So going into that Edit Ship drop-down menu, we're going to click QA/QC report. We are going to generate that report. The QA/QC report is going to capture the same information we saw in the QA/QC window. We will see if a specimen was scanned with our eyes manually or if specimens were evaluated with a barcode scanner. We are also going to see the pass, fail, and not performed status. As a reminder, it is the lab's responsibility to resolve any of the failures of the specimens evaluated. Specimens may need to be relabeled because the barcode scanner could not read the label on the specimen that needs to occur. If specimens are in the wrong positions, they should be placed in the correct positions. If incorrect specimens are on the shipment, they should be removed and replaced with the correct specimens. QA/QC should then be repeated until all your failures have been resolved to passes, and we want 100% pass on those specimens evaluated. What that means is you may have different percentages of specimens to evaluate per container depending on the specimen type. For example, if you are performing QA/QC on PBMC samples, they need to be maintained in a cold environment in liquid nitrogen as long as possible, and you do not want to break the cold chain. You may be required to only evaluate one specimen per row in the QA/QC process, which would be approximately 10% evaluation of specimens, but that 10% needs to be 100% passing. However, if you have a different specimen type, for example, FFPE blocks, you may be evaluating all 100% of the specimens that are FFPE because at room temperature, they are stable and you are unable to impact the specimen condition by keeping them at room temperature. And in that case, you would be evaluating 100% of samples in that scenario. Please review your project documentation provided by your clinical trial network on your requirements for QA/QC. Now that we've performed QA/QC, I'm going to go back into Edit Ship, and I'm going to review our tabs to make sure everything looks correct. So I will navigate to the General tab, the Shipping Destination tab, the Contact at the Sending Lab, the Shipment Notes, and the Shipment Contents. And I will make sure that everything looks the way it should, and then I'm going to click Ship. LDMS is going to create our shipping file and move our shipment out of pending and into shipment history. Let's click OK. You can also see our data file has been downloaded, and we have shipment number 248. Now let's navigate to shipment history. Here we can see our shipment number 248 is the first one listed here. If for some reason I cannot find where our data file downloaded to, I can always go to the View drop-down menu and download the shipping file once again. I am now going to navigate to a different lab database, and we are going to walk through importing a shipment. So I'm going to navigate to Shipping and into Receive Shipments. You will see here features called Import As Is and Import Directly into Storage. Selecting Import Directly into Storage will allow our import specimens to be placed in the shipping import freezer in the storage module. I meant to go to storage. In stored samples, we are going to navigate to that shipping import freezer. Here we are, our shipping import freezer. This is a virtual holding tank similar to any intake freezer in your laboratory. This gives your imported specimens an initial virtual storage location, and then you will move those specimens out of the shipping import freezer into their forever home within your virtual storage configurations. So now let's navigate back to Receive Shipments. So I'm going to click Select File. And I'm going to choose that shipment file. And I'm going to select Preview Shipment. I will review all the details of our shipment here, looking at our general, our shipping destination, our contact at the sending lab, our shipment notes, and our shipment contents. Further down, I'm able to view the specimens themselves to the shipment and how they're organized within the containers if I click View. Now I will scroll back to the top and I will confirm our temperature is dry ice. And then I will scroll back down to the bottom of the page and I will select Receive Shipment. We will click Continue. We can now see our shipment is the 356th shipment, 356. So now let's navigate to shipment history. And we will see our newly imported shipment here. I can now perform QA/QC through the, I can now perform QA/QC on this received shipment. And I would perform QA/QC in the same way I did as an outgoing shipment by reviewing the specimens on the shipment, by using the barcode scanner, or by using the pass/fail buttons and confirming that I have received the specimens as expected. Now we are going to go to that shipping import freezer. I have navigated to the shipping import freezer, and now scrolling down to the bottom, we will see our shipment here. From here, I can move our boxes or the specimens into their correct storage locations using any of the methods that we walked through earlier in the storage module. I can use the Move This Item feature, or I can use the barcode scanner to scan the specimens into their specific locations. I could also use the Actions drop-down menu to utilize the Move Stored Specimens filter search, or by using Move Storage Items. So next, we will move into the test results module in LDMS, where labs can track assay results of their tested specimens for supported assays. The test results module allows the labs to define their experimental design, including control, calibrators, and assign samples from their LDMS database for evaluation. Testing results are automatically sent to the DMC, and result reports can be generated for internal net records as well as for clinician use. And our most recent web LDMS update, LDMS for Web now has robust support for pharmacokinetic assays. So the test results module is going to have a test grid here, where all of our test results are going to be listed and assigned a run ID. You will also see the test name, the run date, the tech initials, and the review status. To create a new test run, we'll go to the Add New dropdown, and we will click Add Pending Results. I will then select our test name, which is going to be Abbott Real-Time HIV-1 RNA. I will then click Continue. I will then fill out our run date, which is today. And I will type in my initials for the tech initials. The input volume will be 0.6 milliliters, and the prep method will be M2000SP. And I will make a comment saying we are creating test results. So now we are going to click Save. This added our test run to the run grid, which will give me a run ID. So now we are going to click Edit of these test results. And this time I will navigate to the Results tab, where we have our controls, specimens, and unmatched results grids. The control grid here, starting here, you will notice that 3 controls are listed currently. By clicking the Add Control button, I can then add additional controls by selecting something I've already added to our database or previously used. I'm going to select this lot number, and then I will click Add. Now we can see that has been added. In our specimens grid, I can see the specimens from our database by clicking Add Specimens here. And these are specimens that you will add to the specimen grid for evaluation. So let's utilize some filters. I'm going to filter on collection date. and choose some specimens that we accessioned into our database today. So I'm going to choose some double spun plasma samples, and I will click Continue. And as you can see, I have these samples for evaluation, and I have these 4 controls. I will now click Save. I can now go to the Edit drop-down menu, and I can click Pending Test Results Report. It will generate this report. This report is going to show us the list of 4 controls and 3 specimens that we are having evaluated. I can take the report to our bench and perform our analysis, and I even have 2D barcodes for our specific specimens we are evaluating that I can scan into our assay equipment. So I can also generate 1D and 2D barcode reports, as we've discussed previously today. And these will give us the list of specimens on our test run with their 1D or 2D barcodes. So we are going to edit, and we are going to go to the Results tab. Once I've completed our analysis and I have our results file, I will go into our test run by clicking that Edit drop-down menu and navigating to that Results tab. Now I'm going to scroll down to the Unmatched Results from File. We are going to upload the file. There we are. You'll see I have a confirmation note asking if I would like to add in the plate comments as well, and I'm going to click Yes. And you may also notice that there was a flash of yellow at the top of the screen. That was the auto-matching of the results to the controls. Auto-matching occurs when the global specimen ID or other specimen ID aligns with the sample ID in your evaluation. So in this scenario, our control names aligned with some of the sample ID names in our result file, and auto-matching occurred here. Conversely, the specimen results did not auto-match because they did not align with the IDs in the result file, so those results are still left blank. When this is the case, we can manually drag and drop our results from the unmatched grid to our individual specimen results. If for some reason I drag the wrong result, I can always drag it back down to remove it and drag up the correct one. Now, once I have associated the results to our specimens for evaluation and our controls, I can click Save. And this will allow me to go to the Pending Test Results view and allow me to update any results for those specimens. We are going to click Complete. When I click Complete, this moves our test run into the completed phase, which allows me to perform the review process. When I open the edit window of the completed test results, you will notice I now have fields that are grayed out. These are open fields. There are open fields to provide our reviewer details. And I also have a tab for our control results, as well as our specimen results. In our specimen results, you will see that I have a column for system sensors that were automatically applied based on the limits of the analysis. I can also apply user sensors to any of these specimens. And as I hover over any of these sensors, we get a text bubble telling us the definition of that sensor. These definitions are also listed in our user manual. The Control Results tab has system sensors applied as well. And if I navigate to the General tab, I can also apply user sensors to the entire run. Then I can add our reviewer details. and I will leave my comment. And I will click Review. This moves our test into the reviewed status. You can see that the Edit button has been changed to View, meaning that I can no longer edit our test run. When I click View, this shows me our run details, and you'll notice that everything is now grayed out, and I am not able to update any of the information. From the drop-down menu, I can click View History of our run, seeing when I completed the run and when I reviewed the run. I can also generate the reviewed test run report. This is going to be an internal document giving us a summary of our run. No, that wasn't what I wanted. Let's do this once more. There we go. So this is the reviewed test run, or this is the reviewed test run report. This is going to be an internal document giving us a summary of our run, including administrative information at the top, and then the controls and specimens that were evaluated, as well as their test results and sensors applied. Last, we are going to run the participant report. The participant report can be provided to clinicians. It includes information about the participant, enrollment, visit, specimen, and test results. If for whatever reason I need to set my results back to pending because I need to upload a corrected file, I can go to the Edit drop-down menu, and I can click Reset to Pending, which will require me to define why this is being reset. And this will be captured in the history as well. Now, although labels can be generated from specimen management, storage, and shipping modules, the label module is where users can generate labels for larger numbers of specimens, as long as those specimens exist in the LDMS database. There is also a custom label function where users can create their own label definition defaults for internal projects. The last module we are going to look at is the reports module. Labs can utilize the reports module to view standard reports generated from their LDMS database across many categories in LDMS. These queries and the relevant generated reports are standardized, formatted, and maintained by Frontier. Users can download reports as different file types, such as CSVs and PDFs. So we are going to look at standard reports to begin with. We have certain categories of reports that we have predefined and pre-formatted. The first report we are going to look at is an administrative report, and we are going to look at the transaction log report. So we are going to set the criteria to start date, and I am going to choose today. I can generate the standard report as PDFs or as flat files listed below. For now, let's generate the report. So as it is loading, we are loading up that transaction log report. And when it loads, you will see that I have performed many transactions today. And that transaction log is going to be an audit trail. This may be requested as part of your end user validation or by audit or regulatory bodies as well. The transaction log is going to show us who performed the action, the date and the time that the action occurred, the transaction ID, and as well as the actual event that took place. We'll also list transaction types, whether it was an update, a removal, or an addition. This report is taking a little while, like they noted, so we're just going to keep moving since we're running a little low on time. This will let me, there we go. Of course it downloaded. So now we can just quickly look at the transaction log before we move on. We can see that there are many different transactions listed on this report. But now let's continue. Another report we will discuss is the user event report. This is a new report available under the admin report category and shares all events that occurred during the specified filter criteria, working as an audit trail. It tracks when the user signs in and signs out, in addition to the other items such as the transaction ID range. If more detail is desired on certain events, you can cross-reference the report with the transactional report. But now let's generate it. I'm going to filter by event date and make it today, and then I'm going to generate the report. Hopefully this one doesn't take as long. Excellent. So we can see this report shows us every event that occurred today. And we can see here we have that reason column. That's that reason for deletion. So let's find the item I deleted. So we get past all these ops auto functions. Well, because this is such a long report, I'm having trouble finding one of my reasons, but the reason for deletion will be listed in this column next to the item that I have deleted. So now we are going to talk about another report. This one is going to be under the specimen category, and this is going to be the specimen processing report. So I'm going to choose our filtering criteria as specimen date. We are going to choose today, and we are going to click add. And this is going to generate the report based on the specimens that were collected specifically today. And here we can see we have those specimens that were collected. Actually, let's look at that a little bit more. This report is organized by the primary specimen and its associated aliquots, similar to how a participant report is organized, except this is going to be in page format. We are going to see all of our overall specimen details, specimen type, additive, volume, collection date, received date, collection time, received processing time, and the processing technician initials. We will see the information for the associated aliquots as well, including frozen date and frozen time. This is a great report to see if you have any gaps in your data, and you will be able to see at a high level if you are missing fields of information, such as processing time or frozen time. Using this report to help find those gaps can help you resolve data issues before any queries may be issued to your lab. One last thing we're going to look at is the specimens not in storage report. So we are going to go to the category of storage. We are going to do specimens not in storage report. I'm going to filter by project. We are going to filter on Frontier. These are all the specimens that I accessioned today but may not have stored in storage of LDMS. Ideally, we want this report to be blank, meaning that all of our specimens based on our filter criteria have storage locations in the storage module of LDMS. This report is going to be particularly helpful if you're participating in clinical trial networks that require the use of storage module of LDMS. If you generate this report daily or weekly, depending on how quickly you are accessioning samples into your database, this can help you make sure that you are following through on all of your necessary steps. With this report, you would want to go through and find all of these individual specimens and assign them your respective locations in the storage module. One last thing we are going to discuss is the Custom Reports Builder. This function allows users to create reports using any of the data fields captured by LDMS. Queries are customizable, allowing labs to cherry pick those data fields most relevant to them. And local queries can be saved for reports that labs may need generated regularly. As mentioned earlier, reports can be exported as different file types, such as a CSV. Now, before we conclude, I wanted to see if we had any questions about what we've discussed today. I don't see any questions in the chat, but please feel free to let me know any of your questions, whether in the chat or if you'd like to raise your hand or unmute. Yeah, I'm going to take that there's no questions. We don't have any raised hands. Nobody's unmuting. We don't have anything in the chat. So I guess I will say this concludes our monthly web LDMS introductory webinar. I'd like to thank all of you for attending today's training. If you're interested in learning more about LDMS, we have many training opportunities available, including webinars, video tutorials on our Frontier Science YouTube channel, and additional training materials at our ldms.org website. For project-specific training sessions, we encourage labs to reach out to our LDMS training team. And additionally, if you have any questions about LDMS, please do not hesitate to contact LDMS user support via email, phone, or by using the Contact Us utility on the ldms.org website. Again, please do not hesitate to reach out if you have any questions. We are happy to address any concerns you may have. Lastly, if you have not already, please input your name and lab ID in the chat for all people participating from your computer screen. And one final reminder, you will receive an email with the link to the proficiency exam following this webinar. Please successfully complete the proficiency exam in order to receive your training certificate. You will receive your training certificate after you have passed the proficiency exam. Now, if we have no other questions, that is going to conclude our introductory training. Thank you so much for your time, and I hope you all have a wonderful day.